Okay, where is the variable? It is an exponent. So this is what we would consider our exponential equation. Okay, so we're going to solve that. So just like we would solve a normal equation, we want to isolate it as much as possible before we bring in our identities and properties and such. So what is the first thing that I could actually do here? I could subtract that 5, so let's subtract that. So I have 4 times the 2 raised to the 2x minus 1 equal to 24. Can I do something else? I can divide that 4 on out of there. That does get me a step closer. So now I have 2 raised to the 2x minus 1 equals 6. Okay. So now we're kind of at a standstill. Now is where we bring in our properties. Here's where we do our maneuvering. All right, this is an exponential function. What is the opposite or the inverse of exponentials? The log, right? So if I have a base 2, how could I get rid of this base of 2? Like I bring in that inverse of log base 2. So that's what we'll do. So I'll bring in a log base 2 on both sides. Okay. We can do that as long as we do to both sides, right, to keep that balance. We're not changing that value. Now, this log base 2 does what to this base 2? They're out. They cancel each other out. And that is exactly what we wanted to do. So we are left with, on the left-hand side, just what that x power was, which was the 2x minus 1, equal to the log base 2 of 6. Now what we're going to do is we're going to go through the steps of isolating, and then we'll go back to the calculator and find our answer. So what would be the next step to isolate your x? Add the 1. So that would give us 2x equals the log base 2 of 6 plus 1. And one more step. Yes, we'll divide out that 2. So we end up with x equals log base 2 of 6 plus the 1 divided by the 2. Now, your log base 2 of 6, we're going to go in and do our change of base so that we can figure out what that value is. So tell me what our change of base is going to look like. It's going to be what? Log of what? 6 divided by log of 2. And then plus your 1 divided by the 2. So put it in the calculator. Put it in your calculator exactly like that. Okay, so we end up with 1.792. Any questions on that one? Okay, so you will have to use that change of base, not all the time, but every now and then. So maybe you might want to rewrite that down on your notes when you're doing this at home for homework. Okay, we're going to approach this the same way we approached the exponential. This, however, is log, right? But we're still going to kind of keep on the same track. We will use a different strategy at the end, however, because it is log. So I'm going to ask you again, where is your x? Where is it inside the equation?
It's the log.
It's inside or it's embedded in that log, right? And last time it was embedded or it was up in the exponent. So we're going to do the same thing. In this case, we want to isolate that log first. So if we want to isolate our log, what would we do first? Yes, we can divide that 3 out. So let's do that first. So those would cancel. We'd have log base 2 of 3x equals 3. So we have the log by itself. So now we need to go after or somehow get that x out of there. So to get a hold of the x, what's got to go? The log's got to go. Okay? So this is a log base 2. How could we get rid of a log base 2?
Rewrite it.
Rewrite it as what?
The next one.
What can we bring? What can we introduce into the equation that would get rid of it?
Base of 2.
Base of 2. Remember, your log and your exponent are inverses, right? So if I bring in a base 2 on both sides, I don't change the value, right? Because I'm doing the same thing. But that will enable us to use our inverse property or identity property and do what? Cancel. So we bring that in. So we'll bring in a base 2. So when you do that, be very careful, because what happens when you bring in the base 2, everything that you had gets moved up, and now those are all exponents. So again, like we did before, this base 2 and this log base 2, what do they do to each other? They cancel each other out, and all we're left with is what? 3x. Over here we have 2 to the third power, which is what? 8. So we have 3x equals 8, or x would be 8/3. So 2 point something?
2.6.
2 points. This is the repeater. 6, 6 repeating. So we do 6, 6, 7. So on the left-hand side of the equation, we have natural log of 2x minus 3 plus natural log of x plus 2. How can we rewrite that? Multiply. So we would take the natural log of 2x minus 3 times x plus 2 equals, what can we do on the right-hand side? How can we rewrite that? That power, we're going to move him back over, right? So that would be natural log x squared. Okay, how am I going to multiply those two binomials together? We're going to use our FOIL. So let's use our FOIL. So we would have the natural log. Your 2x and x would be 2x squared. Okay, your outer. So your 2x and your 2 would be 4x. Your inner, negative 3 and x would be negative 3x. So that would be what?
X.
Plus x. And then your last, negative 3 times 2, negative 6. Okay. All right, here's another popular little property that we're going to use. If I have a natural log here and a natural log here, what happens to them? They just go ahead and cancel out. They kind of negate each other, don't they? So we'll cancel them out.
You wouldn't have to use the 8?
No, because you have the natural log on either side. So that leaves me with the 2x squared plus the x minus 6 equal to x squared. What kind of function is this? Quadratic. How do we solve quadratics? Set them equal to 0. So let's set this equal to 0. So move your x squared over. And what's that going to give you? Oh, yes, you're right. X squared. Oh, because I didn't. There. Sorry. X squared plus x minus 6 equals 0. Now we need to do what? Factor. Let's use our x method to factor this thing. Okay. What's going to go above? What's going to go below? 1. What's your sign combination? Negative, positive. Factors of 6 subtracted give you 1. What are they? Which one's the positive? Which one's the negative? Oh, yes, 2. Thank you. All right, let's drop it back in. So x minus 2 and x plus 3. So solving it, x would be what right here? 2. And this one would be negative 3. Are those going to both be answers that we use? Let's think about our natural log. Let's think about what it looks like. Doesn't it do something like this? Doesn't it kind of come up and do this? Does this have a domain restriction? X's are not going to be what? Negative. So what do we need to do here? We need to take out the -3, right? Because nothing exists over here, right? Nothing exists. So when we have that same base, very simply they will negate each other. 3x equals to 15, or we would get 5. Your second one, they are not the same base, but can we manipulate this one? Is 4 a multiple of 2? So how could we rewrite the 4? 2. So we could rewrite 4 as 2 squared times the 2x plus 1 that's already there. And then what can you do? Now you can cancel. Now you've got that same base and you can cancel. Okay? Can 254 be written as a base 7 like we did these two up here?
Nope.
No. So that's going to throw you into option 2. You're going to have to bring in what? Log. We're going to bring in the log. Okay? So we would bring in, I have enough room here. We're going to bring in the log of both sides. So we would have log of 7 to the x equals log of 254. And what does that enable us now to do? What are we going to do with our power?
Bring them to the front.
We're going to use our power property and move him to the front. Exactly. Okay? So then that would give us, I'm going to swing back up here. That's going to give us x times the log of 7 equals the log of 254. Okay, your goal is to isolate your variable or to find what x is, so what would you do? You need to solve for x. How are you going to get the x by itself? What needs to be moved? Yes, good. Okay, so you would have x equals, now divide out your logs, and what's that going to give you?